Okay, here's something a little different today from the XJet channel, and it's my lathe. The reason I'm doing this is I'm actually just turning up a little adapter here because I've got to balance an EDF unit, the one out of the little Hobby King Dolphin. This EDF impeller is wildly out of balance, and I've noticed that one of the blades actually is quite worn. So I'm going to have to balance it. And to balance it, I'm going to make up a little adapter that will slide in there and allow me to sort of suspend this with very little friction so that I can rotate it. Now I could have taken the motor apart and used the motor bell and everything, because sometimes the motors are unbalanced, but I thought, no, I'll just make up a little adapter and balance the impeller first and see how that then works. So what I've got is a piece of aluminum in the lathe, just here, which I'm turning down to a size that will fit inside there, and I'm going to have a little sharp bit poke out here, so I can then have two fine points which I can actually just hold at my hand and then get the balance point on the impeller. But I thought, well, while I'm doing that, why not make a video about lathes and why every hobbyist should have one if you can afford it. And they're not that expensive these days. They're made in China, so like everything made in China, they actually turn out to be pretty cheap. Now this is the chuck of the lathe, this bit here. This, you know what a drill chuck is like. Well, this is the lathe chuck. This is a 4-jaw, so that means it has 4 individual jaws to grip the work. Now I use a 4-jaw chuck rather than a 3-jaw chuck, because although the 3-jaw chucks are self-centering, a 4-jaw chuck allows you to center more accurately. Nothing is perfect from a manufacturing perspective, so a 3-jaw chuck will get things pretty close to center, but there may be some off-center, which is called run out, once you put your work in there. And well, when I do stuff, I like to do it to a reasonable precision, so I use a 4-jaw chuck so that I can individually adjust each of these little jaw settings to make sure the work that I'm working with is absolutely centered, and therefore I get the best results. Now a lot of people make do with 3 jaws, they're not as anal as me, so hey, that's fine, but 4 jaws also allow you to mount stuff in the chuck so it's off center, so you can make camshafts if you want to, and things like that, eccentric lobes, and that can be really useful if you like a little bit of engineering. And this is quite a small lathe, but it has one really nice feature, is constantly variable speed. Now, if I turn it on, I can then start it up, and you'll notice I've got a speed control. So I can actually vary the speed of the spindle there without having to change belts or gears. It's infinitely variable, which is actually really handy, because sometimes, depending on the material, you want to go a little bit faster or a little bit slower. Sometimes if you're getting chattering, all sorts of things like that. Changing the speed with an infinitely variable amount is really, really handy. But usually only get this on the smaller lathes. The bigger lathes, they have a series of belts or gears, so you select a speed that you want, and then you're pretty much stuck with it until you change the ratios. And this little piece of the lathe is called the tool post. I've actually made this little tool post here because inside the tool post, let me just roll this along a little bit for you. I'll show you what we do. We've got a tool. Isn't that surprising? A tool fits in the tool post. Now the tool is actually some very, very hard steel. It's called tool steel. Oh, who'd have thought? And you grind these, well, I prefer to use tool steel because these smaller lathes don't work that well with higher materials like carbon tungsten carbide. So I use high-speed steel, tool steel, and I grind my own tool bit, so I get the just exactly right angles to get the best cut and get the most out of my tiny little lathe. And of course this tool post sits on something that they call the compound. And the compound is the thing that's got these wheels here. Now if I zoom out a bit, you can see the wheels. Now this wheel moves the tool across, backwards and forwards across the face of the lathe. So that'll change the depth of your cut, or if you're facing, it'll now be a nice smooth cut across the front of the thing. And then you've got another one here, which come around the other side so you can see. This one moves it backwards and forwards along the length of the work. So there. Now there is a much bigger wheel down the bottom here which will move things much faster. So if I come down here, you can see that if I release the carriage, I can actually move the carriage in very, very large movement. It's a big wheel. This is the fine movement. So if I'm trying to, like I'm doing here, I'm turning this piece of metal down to a smaller diameter so it'll fit inside my little impeller for my ducted fan, my EDF. It's going to fit in that hole there. But at the moment, this is about 7 millimeters. That hole is 4.6, so I need to turn it down quite a bit. And so when I'm turning it down, I use the big wheel because I can slide this along really quickly, just peel bits of metal off the work without having to fiddle around with this tiny little wheel and move it really quickly. So there you go. You notice down here as well, there's a thing called a lead screw. This is a big long threaded rod, because what you can do with these is actually cut threads. So if I wanted to, I could engage some gears that will turn this threaded rod and automatically move this carriage along, move the tool post along. And because the movement of this is related to the movement of the work itself, because it's all geared together, it actually will cut a spiral groove, which is a thread, of course. So by changing gears and things, I can cut all manners of different threads on the work that I'm working with. So that's really handy if you need to cut a thread in something you don't have a tap or a die the right size. And this, of course, this bit down here is called the bed of the lathe. And this is one of the factors, when you're buying a lathe, you'll get a couple of measures. There's two measurements when you're sort of specifying a lathe. One of them is the width across the face, that is how far your tool will move across this way and how big a piece of work you can hold, because obviously if the metal's too big, it's going to bang into the bed. If you put it in the chuck there, it's going to be too big a diameter. The other one is the distance between centres, which means the length of piece of work you can work on. So obviously at this end, if you go too far, this stops, so you can't actually cut beyond this point. And so really that's the width. This is a really small one. This is a 10-inch lathe in the old money. They make these now in 12-inch, but you can go up to massive lengths if you want to, 1 metre or more. And this one I think will turn, I think it's 100 millimetres across there. So I can turn bits of work that are really 100 millimetres, 120 millimetres, which is fine for hobby use. Now, you know, obviously you wouldn't use this in a engineering workshop where you're making big bits of metal, but for small stuff, for hobby stuff, it's brilliant, excellent, very, very good indeed. Now, I should point out that these Chinese-made lathes, they're not the greatest precision things in the world. When you get them, quite often, consider them to be a roughly assembled kit, because it really does pay to strip them down, clean them out, get all the foundry sand out of them, and then smarten them up a bit. See, I made this new tool post. One of the reasons for that is because this tool post has a little screw here that I can adjust the height, because obviously this little cutting tool has to be on or very close to the centre line of the work. If it's too high, then it'll rub. If it's too low, then when you go across the face of the work, you'll get a little titty hanging out the end. So because depending on how you grind these tool pieces, this height will vary. By adjusting this screw, backing off the locking and adjusting the screw, I can vary the height of this tool post. And so it's really, really handy. There's a little pinch bolt on the back here which you loosen off, and then you can wind the tool post up and down to get that dead centre. Brilliant. So what I'm thinking I might do, now if people are interested in lathes of this kind for the hobby, I may do a series of videos showing you how to set your lathe up, how to do simple things like turning a shaft down to a smaller size, drilling on the lathe, facing, all those cutting threads, those sort of things. So if you're looking at, if you've got a lathe or you're thinking of getting a lathe, give you an idea of what's involved, and maybe that will get more people using these things and having a lot more fun, making your own bits of hardware. It really is a lifesaver if you need a part made of metal or even plastic. I mean, as you can see, there's bits of plastic in here because you can turn nylon, Delron, acetate, or all the different types of metals and materials you can turn in these and make all sorts of cool stuff. So make your own undercarriage legs, who knows? But if you're interested, put a comment on the bottom of this video, and I've got another channel which I'm setting up which may be more engineering, workshop-y type tips for those people who just want to make their own stuff out of all sorts of materials. And we might start with the lathe. But once we're done with lathes, I'll probably clean the rust off my mill, and I'll show you how to use a mill too, because basically a mill is like a whittling machine for metal. You can just carve metal with this rapidly spinning cutting bit here. You can make grooves and you can cut things to size. Brilliant. A mill is a really, really useful piece of kit if you want to do this sort of engineering at home. And of course, I'll also be doing some welding videos. I promised those a while ago. And the welder you see before you is actually blown up. It's crap, rubbish. It was good, but then it stopped. So I'm not that impressed with this welder. I bought another one, and I'll do the unpack, setting up, and basics of how to do a little bit of TIG welding, because just like machining, being able to weld, being able to glue metal together is really, really handy when you want to make stuff yourself. I'll show you the basics of TIG welding, the basics of MIG welding, maybe a little gas welding and brazing, I don't know. So these are the videos I'll fit in when I'm not doing reviews and not having fun with RC models, and hopefully people will find them useful. If you've got comments, put them on the bottom of the video. Questions on the bottom of the video. If you like the video, give it a big thumbs up. Where's my thumb? There it is. Oh, it's too close. And other people will find this video. So yeah, tell me what you think.